Welcome to Learn Yourself. Today we are going to learn about refraction by the convex lens. And here we are going to discuss the nature, position and size of the image when we are keeping the object at various places in front of the convex lens. So here first we are checking that when parallel rays are falling on the convex lens, at that time all the rays will get collected at one point towards the other side of the convex lens, and that point is going to be the focus point of this convex lens. Now if you have any doubt about what are the convex lens, how many focus point they have and what all are the center of the curvatures for the convex lens and convex lens, then please refer my previous video and then come back to this video. It will be much easier to understand all this terminology. So first case, what we have already discussed this in that video, that when parallel rays are falling on the convex lens, it shows the converging action, that it collects all the rays at one point and that point is going to be the focus point of the convex lens. Now second case, here in the mirror and in the lenses we are following the one thing to check the nature and size and position of the image, that we are starting from the infinity, that these rays are coming, that these rays are parallel but these rays are coming from the infinity. So from the infinity rays are coming, so we are keeping object at infinity, so we are getting all the rays collected at one point, that is F2 focus point. In second case we are taking it little bit closer. Now this is the first case in which we are keeping the object at infinity. Then we have in between C1, F1, then optical center. All these are the points in between the pathways from, all these are the points in front of the convex lens. So here first case we are taking that we are placing the object at infinity. Then we are placing the object near to the center of the curvature. So in between infinity but towards the center of the curvature, and it is known as beyond C1 or it is beyond center of the curvature. So this is going to be our second case. When we are keeping the object over here, which kind of image and what size of image we will get. Then third case we are taking that we are keeping object at center of the curvature, that is C1. So this is going to be our third case, that slowly we are going towards the optical center. So here we are keeping our object. So we will discuss that where we will get the image and how we will get the image. Then in next case we are going to keep the object in between center of the curvature and focus point here. So that is going to be our fourth case. So that is here. Now fifth case is we are going to keep object at focus point. So that is going to be our fifth case, that when we are keeping the object at focus point where we will get the image. And the last case, and that is the sixth case, that when we are keeping our object in between optical center and focus point where we will get the image and how we will get the image. So these 6 cases we have discussed when we were studying the concave mirror, and we have seen all these 6 cases for concave mirror. Here we are going to discuss all these 6 cases for convex lens. So here I have shown the 4 cases, and after this we are going to study the 5th and 6th case. So let us start from the first one, which we have already discussed, that when the objects are at the infinity and all the parallel rays are falling on the convex lens, we will get a focus point, we will get image at the focus point. Then second case, when we are keeping the object beyond C, beyond center of the curvature, or we can also say in terms of lenses that this is 2F1. This is first focus point and this is second focus point. But here we are going to maintain it C1 so that we will not get confused in between 2F1 and F1. So this is going to be our center of the curvature 1 and this is going to be our center of the curvature 2. So when we are keeping the object beyond C1, there will be two rays which will give us image towards the other side of the lens. Now it is not going to happen that only two rays are coming out from the object. There will be many rays, but to see the diagram clearly and to see the action of the rays, that how they are falling on the lens and how they are getting refracted, to see that we are mentioning only two rays. And these two minimal rays will give us idea about that where we will get the image and how we will get the image. So here this is an object, AB is an object. This is object here, and that we have kept it beyond C. It is not at the C1. It is beyond C1. So far from the C1, and it is not towards the lens. It is just far from the lens. So it is beyond C1, and when the rays are passing through the lens, one ray will just pass from the optical center. When any ray is passing from the optical center, it is not going to refract. It is not going to bend. It will choose the straight path, and straightways it will just go out from the lens. So this ray will be straight rays. So another ray which is coming out from the object, that is getting refracted here, and that is meeting this another ray which is passing from the optical center over here, and that position is in between focus point and center of the curvature. The second focus point and second center of the curvature, that is other side of this lens. So in between these two we are getting the image, and an image is A dash B dash. The image is diminished, an image is real, and it is inverted. It is upside down image. Then in third case, when we are keeping the object at C1, that AB object we have kept at C1, so we are getting the refracted image over here, and that is at C2. So when we are keeping object at C1, the other side of the lens we will get the image, and that is C2. It will be of the same size, real and inverted. Now in fourth case, when we are moving towards the F1, so we are keeping our object in between C1 and F1, in between center of the curvature and focus point. At that time we will get the image beyond C2. That means we are getting the image beyond center of the curvature, and that is the other side of the lens. So we are getting the image enlarged, that is very big compared to our object, real and inverted. So in all these cases we have seen that we are getting the inverted image. In this case we are getting the diminished image. In this case we are getting the same size image, and here in this case we are getting the bigger size image compared to the object. So here we can note down like this, that when we are keeping object at this different position, we are getting image at all this location. That when we are keeping the object at infinity, we will get the image at F2, and it is highly diminished. Whereas when we are keeping the object at second, that is beyond C1, we will get the image in between F2 and C2. When we are keeping the object at C1, we are getting the image at C2 and same size image. When we are keeping the object in between C and F, we are getting the image beyond C2, and the image will be enlarged. In all of this case, we are getting the image real and inverted. All of these cases we are getting image real and inverted. So when you will remember like this, it will be easy for you to discuss each and every case, and you can also remember that what will be the nature and size of the image. Now let us discuss the last two cases, that when we are keeping the object at F1 and we are keeping the object closer to the lens. So our fifth case is when we are keeping the object at F1. At that time we are getting the image at infinity, and that image is going to be highly enlarged and real and inverted. So when we are keeping the object at F1, we are getting the image at infinity. So here I am going to mention 5, and here I am going to write at infinity and highly enlarged. Now last case, when we are keeping the object beyond F1 or towards the convex lens, that is in between focus point and optical center. When we are keeping the object AB, we are getting the image towards the same side of the convex lens, and it is going to be virtual and erect. So towards the same side we are getting the image over here. That sixth case is there, and when we are keeping it over here, we are getting the image after C, that is center of the curvature, and this is C1, that center of the curvature 1. After that we are getting, but we are getting towards the same side. So for here the image is, for the sixth case, the image we are getting it over here. It will be enlarged, virtual and erect image. So all these are the cases that when we are keeping the object at all this position, we are getting the images like this. So all of these cases, for the real and inverted, only this we are getting virtual and erect. So let us understand all the cases like this. All these black numbers suggested that these are the position of the object, that when we are keeping at the infinity. So we are getting image at f2 and it will be highly diminished. When we are keeping the object beyond C1, we are getting in between f2 and C1, it will be highly diminished. Then when we are keeping the object at C1, we will get the image also at C1 towards the other side, and it will be same size. When we are keeping the object in between C1 and F1, we will get the image beyond C1. So that will be enlarged. When we are keeping the object at F1 position, we will get the image at infinity, it will be highly enlarged. And when we are keeping the object in between F1 and optical center, that case will be the sixth case, and we will get the image towards the same side, and that will be towards the beyond C, and that image will be enlarged, virtual and erect. So for the case 1, 2, 3, 4 and 5, all the images are real and inverted. And what will be the size of the image? That for the first case it is highly diminished, then it is same, enlarged and highly enlarged. So from the point size it is growing bigger, and at the last it is virtual and erect. And sixth one is virtual and erect. So if you will remember like this, all the cases for the convex mirror, it will be very easy for you to remember that what all are the position of the object, what all are the position of the image, and nature and size of the image. Now we are discussing two cases for the concave lens. That first case is when we are keeping the object at infinity and all those rays are falling on the concave lens. Those rays, when we are extending towards the same side, we will get the image at focus point F1. So this image is highly diminished and point size, and it will be virtual and erect. Whereas in the second case, when we are keeping the object in between center of the curvature, that C1, and in between F1 and C1, we are getting the image that is in between focus point and optical center. And that image is also virtual and erect, but it will be highly diminished. So it is very small size image, as we can see that the size of object compared to the size of object, that image size is very less, and it is going to be at the same side. Here also the image we are getting at towards the same side. So from the convex lens and from the concave lenses, we are getting the images from that convex lenses images, we are getting the other side of the lens. Whereas in the concave lens, we are getting the images towards the same side of the lens. So hope this video has solved your doubt. In coming videos, we are going to solve many more important concepts. So don't forget to subscribe, learn yourself. I'll see you in next video. Till then, keep learning, keep sharing.